Good morning. Today is I'm going to explain module 2 basic relationship between pixels. So here in the spatial domain, we look into the number of pixels available in the image, how the pixels are located and the pattern of the pixels. All these things we are going to discuss in this topic. It is called a basic relationship between the pixels. So here mainly we have 6 subtopics: neighborhood concept, adjacency, connectivity between the pixels, paths, regions, then finally boundary and distance. So what do you mean by neighbors? In any image, we have 2 coordinates, x and y. Suppose you can consider 1 pixel. So we'll consider 3 cross 3. So like this. So this is what we call as center pixels, f of x comma y. So here in the neighboring pixels, we are going to consider 4 neighbors, 4 diagonal neighbors, and 8 neighbors. That it is called as N4P, NDP, N8P. N4 is nothing but only look into that vertical and horizontal. So example, these 2 pixels and these 2 pixels will be considered as N4. Only vertical and horizontal pixel is called as a N4. Similarly, ND pixel is nothing but this is what the center pixels, diagonal pixels for this, and this. This is what diagonal pixels. So considering both N4 and ND, it will become N8 pixels. N8 P pixels. So that is we considered, for example, here we 3 cross 3 pixels, totally 9 pixels. Center pixels considered as a P of x comma y. Then the neighboring pixel will be represented like that: x minus 1 comma y, x plus y comma 1, x y minus 1, and x y plus 1. And diagonally it will be same thing. The combination of these two will get n 8 pixels. So now the same concept the mentioned here in the diagram. So very clearly it indicates the different colors. The yellow colors indicates here. The yellow colors here it will be called as N4, and other color it will be called as N8 pixels. Sometimes the pixel is outside the digital image. If the pixel P is on the border of the image, only we will consider the border, that it is called as borderline pixels. Okay. Now we'll come to that adjacency. What do you mean by adjacency? Same thing here. 4 adjacency, 8 adjacency, and M adjacency. So in case of 4 adjacency, 2 pixels P and Q with values from V are 4 adjacent. If Q is the set of N4P, that is what 4 adjacency. And 8 adjacency here, this is what 4 adjacency. 8 adjacency, 2 pixels P and Q with the values from V 8 adjacent, N8, in the what previous concept what we discussed, that is what N8 concept. And then M adjacency, that is a little bit different. 2 pixels P and Q with the values from V are M adjacency. So M adjacency, either we considered N4 or N8. Sorry, N4 and ND adjacency. For example, Q is the N4, Q is the ND, and the set of N4, so here has 2 pixels, whose the values will be called as M adjacency. See here, 8 adjacency and then M adjacency. In here in the M adjacency, please look into that. So this is what considered center pixels like this ND. Sorry. So here ND. Then N4. So here we'll consider. So but here same thing. N8 diagonal ND, but this is not considered as a diagonal. We'll consider as N4 like this. That is what we call as M adjacency. And what you mean by path? Pixels P with coordinates the border lines. The sequence will be called as path. The path should be like that. See here, 8 adjacency what we are going to consider in the V12. So this is very important. The coordinate what we considered V12. Then here V12 with M adjacency and 8 adjacency. See here, the path 1 to 3, 2, 3 to 3. So here combination, see here, 1, 3, 1, 2, little bit mismatch here, like this. From we start from 1 and 1 is box through like this. Okay. So connectivity between the pixels, one pixel to another pixel, that will be called as connected in S. The path will be existed. So here, so this is what the concept will be measured, distance measured. Euclidean distance what we are going to use to measure the pixels. Either it may be N4, ND or N8. This is what we call as basic relationship between the pixels.